Artificial intelligence is maturing rapidly. This is the AI era where humans and machines work together to achieve something greater than what either could do alone. AI promises to dramatically improve productivity, to unleash innovation and discovery, and to make the world a better place. But for that bright future to come to fruition, we must be able to trust AI. As AI percolates through every sector and industry, how do we know if we can trust the AI tools we use? How do we know if we should? Most importantly, what can we do so that we can trust it? This is the challenge of developing trustworthy AI. Trust has a real impact on organizations and society. As AI is used at scale, impacting millions of people, the decisions we make now with AI will determine just how much value it can deliver and how much trust it deserves. In a general sense, trustworthy AI creates maximum value because its risks are known, mitigated, and controlled. It grows out of an AI lifecycle that is guided and managed by an inclusive set of stakeholders. Trustworthy AI does not happen accidentally, and in some ways, we as a world are behind on taking action to ensure this powerful technology is one we want and one we can trust. When transformative technologies emerge, their development occurs along three streams of progress. These streams run concurrently, but they do not usually move at the same pace. We can use the example of the consumer car. The first stream is research and development. This is the technical creation and improvement of the technology. It often takes place in academic research centers as well as in businesses. Across the three streams of development, this often moves the fastest. With the example of the consumer car, research and development was advanced by automotive manufacturers. The second stream is technology application. When the underlying technology is ready for market, it can be adopted and used at scale. Here, a larger set of stakeholders must contend with how to integrate the technology into existing systems and ways of working. As consumer cars were adopted at scale, there became a need for better paved roads, gas stations, and parking lots. The horse-drawn carriage businesses went out of business, and the carriage drivers needed a new job. And with the ability to easily and cheaply travel long distances, consumers began making different choices about where to live and work. As you might expect, this stream often moves somewhat slower than research and development, since innovation precedes adoption. The third stream is where really trust comes into play. It is by using a technology at scale that we learn about its risks and how to manage them. When the first car rolled off the assembly line, there were no seat belts or traffic signs. There was a lack of laws and regulations around how cars could be used, such as speed limits. Inefficient engines led to harmful emissions. Pedestrians had to learn how to safely navigate a city on foot with so many new machines in the streets. Over decades, changes and improvements to how cars are manufactured and used have created reliable, safe machines that we trust. But it took a while to get there. With AI, the third stream is progressing slowly. Organizations are deploying AI in every business unit for different use cases. People are using it in their work and personal lives. The technology is already transforming society around us. How do we approach this fast-moving technology with the mind towards trust? No two AI applications are exactly the same. They differ depending on the training data, the algorithms, the technology infrastructure, the people who use AI, and the decisions they make with it. There is no simple checklist that, if satisfied, always results in trustworthy AI. Each AI application must be examined and judged on its own merits. To structure how we think about and address AI trust and risk, it is helpful to use a framework. In the Trustworthy AI framework, there are 7 areas or dimensions impacting trustworthiness. Each dimension represents challenges and considerations. Importantly, not every dimension is relevant to all AI applications. What may be critical to one use case is not a factor for another. The task is to identify the applicable trust dimensions for each AI system and use that insight to build and manage for trust. Let's explore deeper what each of these domains mean for AI. Fair and impartial AI is unbiased in its outputs. Humans have many biases in our thoughts and interactions. When we discuss biased AI, what we are really talking about is the data. For AI, the data used in model training can reflect the different biases that are present in society today and in the past. Of course, AI models do not have any sense of why bias is a problem. Machines do not understand equity nor the consequences of biased outputs. Instead, an AI model functions according to its data. And if the data is biased, that the AI will perpetuate it. For example, imagine an AI tool used in resume screening. Its task is to identify the best job candidates for an executive position. Its training dataset contains the attributes of prior executives, and the model extracts details to score new hires. Importantly, the dataset does not include gender or ethnicity as a category. The AI begins screening resumes looking for correlations with certain schools, geographic locations, age, hobbies, leadership style, and more. And despite there not being any intentional preference based on race or gender, the AI reports back that the best candidates are all Caucasian men. How did that happen? It is likely the organization had a history of tending to hire and promote one gender and demographic to executive positions, and that bias was reflected in the dataset. Yet, that's not the full story, since gender and ethnicity were not categories. Instead, where people live, go to school, what they do for fun, and other details of their lives sometimes correlate with ethnicity. The AI model screening resumes has no idea what a human is, much less how they look. And yet, because of the data, it was biased in its outputs. Bias is not always discriminatory or malicious. A malfunctioning sensor on a manufacturing line could record incomplete data, leading to a data set that suggests everything is working well, even if it isn't. Bias can also result from an underrepresentation in the data. For example, an AI application that recommends nutrition plans may be highly accurate and helpful for ages 20 to 60, but then less effective for people aged 90 to 100. Because there are fewer people who live to that age, they are underrepresented in the training data, and the machine simply works better for age cohorts where it has more examples. The key insight is that AI models are susceptible to biased outputs, and the root of the issue is in the data. When we say robust and reliable AI, we are talking about AI's ability to function as intended. There are two components. First, the ability to function in suboptimal environments, and second, the ability to function in the face of unexpected data. Robustness is the AI's capacity to maintain performance under any circumstance. A chess-playing AI remains robust over time because the rules of chess are predictable and static. The environment never changes. Conversely, an AI chatbot operates in the fluid landscape of speech patterns, language, incorrect grammar and syntax, and a variety of factors. The input data is imperfect and suboptimal relative to the training data. A robust AI chatbot continues to perform despite these circumstances. The opposite of robustness is brittleness. When small changes in the environment lead to large changes in functionality, a model is brittle. Ultimately, all AI are brittle to some degree. With enough changes to the deployment and operating environment, functionality starts to break down. Related but distinct is AI reliability. Reliable AI performs as expected even with inputs that were not included in the training data. Imagine an AI designed to find airplanes in photographs. It has been trained on thousands of images of airplanes, and when it computes the photographs, it matches correlations in its training set to what is in the photos. What happens if the plane is shown at an odd angle, or the sun is setting behind it, or a wing is removed? Can the AI still find all the airplanes? If it encounters unfamiliar data and can still perform accurately, it is reliable. A challenge arises when determining whether an output is accurate in the first place. AI can return information with total confidence even when it is entirely wrong. There are also considerations for reliability trade-offs. If an AI application that recommends product purchases for online shoppers is accurate 80% of the time, that may be sufficient. However, an autonomous vehicle that avoids pedestrians 80% of the time is not a vehicle that can be trusted. The key insight is that managing for reliability and robustness is a cross-cutting challenge that depends on the operating environment, the data, the model itself, and the people who validate AI outputs as accurate. Every person values individual privacy, and when we share information about ourselves, we expect the information will be treated with care and in a way that benefits us. Since AI is trained and fueled by data, there are significant privacy issues that need to be addressed at all stages of the AI lifecycle. Sensitive information must be protected from unauthorized access. Individuals must consent to having their data processed and stored. Privacy laws and regulations must be followed, and steps need to be taken to prevent the AI from revealing information it should not. Respecting privacy with AI means creating opportunities for consumers to opt in to data sharing, and it also means establishing avenues for users to express their priorities for data privacy. If personal data is collected, the organization needs to determine the methods to obscure or hide sensitive information or to discard it entirely. Privacy issues can extend to how data is used and shared elsewhere. Car manufacturers, for example, remotely collect troves of data about your car. While you're commuting to work, they're tracking the pitch, roll, and yaw of the engine. This helps the predictive maintenance and gives insight for innovation. What if, however, an AI tool consumes that engine data, infers driving habits, passes it to an insurance company, and your rates are raised? Did you consent to that as a consumer? Where should the privacy line be drawn and who draws it? If users feel their privacy is violated by AI use, they will not only lose trust in the tool, but also in the organization using it. The challenge for preserving privacy and promoting trust falls squarely on the organization consuming the data and deploying the AI. Ultimately, organizations must decide what information to collect, how the information will be retained, how it will be used, and how it will be deleted. Trustworthy AI is secure against attacks from malicious actors. There are numerous attacks and compromises that could lead an AI astray. Consider the kinds of security threats that may be launched to compromise an AI system. Cyber adversaries may use tactics that cause the AI system to output incorrect information or take inappropriate action. By determining how a model works, adversaries may be able to influence or change the data. Data poisoning, for example, is a type of attack where the adversary injects data to contaminate the AI and manipulate the application. In another genre of security threats, adversaries may attempt to trick an AI system into revealing sensitive data or insights. Through prompts or testing, they may decode how an application works and use that knowledge to extract information. Imagine an AI application in a healthcare setting that automates parts of the insurance claims process. In knowing how it functions, adversaries could access sensitive medical data or commit other illegal activities such as fraud. A third attack vector is causing the system to learn incorrectly and function insecurely. This adversary may exploit a known vulnerability, or they may inject a backdoor into a retrained system such that it can be compromised in the future. The consequences of AI security breaches include the exposure of sensitive, proprietary data, which can raise liability penalties or regulatory fines. There is also a risk of disclosing intellectual property and trade secrets. Critically, organizations and people will not trust an AI that is insecure and that will affect the data they consent to share and whether they use AI. As with cybersecurity, the solution is twofold. First, AI systems and their infrastructure need to be designed to withstand known and emerging threats. Second, people who use and manage AI need to understand how to spot and avoid security threats. To trust AI, we want confidence that it will deliver benefits without causing harm. What is harm? Some examples are easy to imagine. An autonomous vehicle that fails to stop at a traffic light could strike a pedestrian. Or a robot in a manufacturing plant could operate in a way that threatens a human working alongside with it. Physical harm is one of the easiest ones to conceive, but many types of AI applications do not carry any physical safety risks directly. That doesn't mean they are safe. There are other harms that fall under the umbrella of AI safety. Take economic harm. Decisions or recommendations from an AI tool can influence whether someone qualifies for a mortgage, receives a job offer, or is eligible for public benefits. For organizations, AI could harm efficiency, productivity, or even violate laws and regulations, resulting in financial penalties. There is also the potential for environmental harm. Training and using AI can command significant energy resources, raising questions about the balance between AI benefits and environmental impact. In some cases, there may even be psychological harm, such as if a user is tricked into believing an AI is human, or if they receive advice or recommendations that negatively influence them. As with other risks, it is important to weigh the degree of safety that is required and the degree of risk that is acceptable. AI safety is not a single measure, but instead a suite of activities and processes that together allow AI to function while mitigating harm. It is a quality that must be observed, tracked, and improved from design through AI retirement. If an AI application makes an incorrect decision or causes a problem, it cannot be held accountable for its error. It cannot face any real consequence nor make a meaningful apology. Instead, AI accountability rests with the people involved in creating and using the machine, much like any other technology. So, what does accountability mean in this case? Most simply, AI stakeholders can explain the system's decisions, the rationale behind the decisions, and understand that they're culpable for the outcomes. Here is the challenge. There is rarely just one person accountable for an AI deployment. Imagine an AI tool used in office administration. It intakes vendor invoices, processes the information, and approves a payment. However, over time, the AI application begins to make errors, rejecting some invoices while overpaying others. The result is extra costs, confusion, and upset vendors. Who is accountable for this outcome? Is it the administrative staff using the tool? Or is it the data science and IT professionals who created the application? Does accountability sit higher in the organization, such as with an executive? The answer to all of these questions is yes. There are many people across the AI lifecycle whose decisions collectively determine how the AI will function and the risks it may bring. Accountability is complex and shared, and each organization must decide for itself how to distribute accountability. Alongside these considerations is legal accountability. Liability laws could apply to instances where AI causes harm to a person or property, and civil judgments against an organization could be costly in terms of financial penalties and consumer trust. With a clear articulation of who is accountable for what, the organization is prepared to address AI risks with corrective actions and establish meaningful human accountability across all AI programs. When stakeholders understand and embrace their accountability, it creates a chain of people who work together towards trustworthy AI. For most, AI is an opaque technology. Users do not often understand the inner workings of an AI model, and they may not be aware of how its operation impacts them. These are the twin challenges of AI: transparency and explainability. Transparency is a cross-cutting factor that impacts all other aspects of trustworthy AI. It permits accountability, reveals bias, encourages fairness and safety, and informs all of the activities around AI governance and compliance. Transparency is not the quality of a tool itself, but instead the way in which an organization promotes the understanding of the system. With transparent AI, data sets are understood, algorithms can be traced back to their training data, and AI solutions can be validated as accurate. All stakeholders need some degree of AI transparency. It informs their actions and decisions, and it impacts accountability. Yet, not all stakeholders require the same level of transparency, and it is up to the organization to determine what is appropriate. Imagine a bank that uses an AI system to score an individual's risk of loan default and determine creditworthiness. An applicant seeks a loan and they're denied based on the AI's creditworthiness score. Consider the stakeholders and the need for transparency. The bank needs confidence that there is no bias in the model training data. The loan officer needs to trust that the AI is accurate. The bank's letter describing why the loan was denied might include the AI-generated risk score, which should be intelligible to the applicant. And if the denial is challenged on the grounds of a protected attribute, such as race or gender, regulators and investigators may require explanation as to how the AI system functions. Related to transparency is explainability, which means humans can understand how a model works and why it delivers the outputs it does. The challenge is to determine who requires explainability in AI function and to what degree. For example, a data scientist may be able to calculate the error rate of an algorithm and present the underlying math. But does that offer much value to the marketer, the business strategist, or the consumer? A lack of explainability limits AI's potential value because responsible and trustworthy AI requires stakeholders to understand in a meaningful way the technology they are using. Having explored the risks and considerations for trustworthy AI, we can now consider how we turn insight into action. We know the qualities of trustworthy AI. How do we implement that knowledge to mitigate risk and help stakeholders manage for trust? Part of the answer is AI governance. Governance means workflows, stakeholders, and technologies are aligned to maximize value, minimize risk, and ensure the AI lifecycle adheres to laws, regulations, industry standards, and enterprise culture. Everyone in an AI organization has a role to play in AI governance. At a high level, operationalizing trustworthy AI takes place across the areas of an organization's people, processes, and technologies. For an organization's workforce, one of the most important investments is cultivating AI literacy. Across the organization, each stakeholder needs a working knowledge of AI according to their role. They need to understand the types of AI, their limits and capabilities, the kind of value they can deliver, the risks they can create, and the policies, laws, and regulations that apply. The AI era will require the workforce to learn how to use AI responsibly. Some organizations may create new roles like a Chief AI Ethics Officer position or stand up an AI Oversight Committee to help guide AI application and governance. The goal is to have all AI stakeholders working in a coordination to address trust at every stage of the AI lifecycle. Process changes are also important. Organizations need to create guardrails that can keep AI development on track and in line with cultures, values, and rules. They also need to insert waypoints for decision making, structured opportunities for stakeholders to come together, assess progress and challenges, and make informed decisions. In this way, AI applications are not simply inserted into work like a piece of software. Instead, the nature and flow of work is transformed to make room for AI governance. Technology investments are the third component of governance. It includes technology infrastructure adjustments to enable security, data privacy, and scale. There are also complementary technologies that can probe AI outputs and support transparency and explainability. This gives stakeholders greater insight into AI function, which is important for managing for reliability, fairness, and responsible use. Together, these changes to people, processes, and technologies permit an organization to methodically govern the AI lifecycle in a way that is compliant and that promotes trust. Surrounding the AI lifecycle is the question of responsible use. As well as considering whether the organization can deploy AI, businesses must also weigh whether they should. Every AI application must receive the question, is it a responsible decision to deploy this system? Each of the trust domains influence whether AI use is responsible, if the model poses risk to safety, security, fairness, or indeed any of the qualities of trustworthy AI. Responsibility is a matter of determining how to address and manage those risks. For risks like physical safety or data security, making a responsible decision is fairly straightforward. No organization would use technology that is fundamentally unsafe or unsecure. But what about risks that are somewhat harder to spot? Imagine an AI application that helps customers virtually try on clothing through an augmented reality app on their phone. They upload a picture and the AI renders an image of the consumer in the clothes. The data set used in training was collected from images in beauty magazines from 1970 to 2000. And the data set underrepresents people of color and people over the age of 30. For example, because of that, the AI application is likely to function more accurately for some consumers than for others. Is it a responsible decision to use this tool? If not, what steps could be taken to get there? What if this application was for patient diagnosis? Responsible AI use can vary depending on where the application is used. Local culture and values matter, and what is appropriate and responsible in one region may not be so in another. This underscores the complex challenge of trustworthy AI. Each application must be weighed in multiple contexts, with the input of multiple people across the AI lifecycle. Making responsible choices with AI is a whole of enterprise activity. Stakeholders include not just the technologists who create the tool, but also the line of business leaders and users, the executives, and even the board. It takes a diversity of perspectives and lived experiences to consider all the ways AI might create risk and the methods to address them. Even as AI is maturing quickly, we are still only at the beginning of the AI era. The expectations are huge, as is the potential value. To get there, we must be able to trust this technology. The decisions and changes we make today will determine just what kind of AI future we are building for our organizations and the world.